about this week's experiment. This is essentially we're in week 3. We are getting ready to go into a holiday break, and this experiment will be a 2-week assignment. So you'll have until September 12th to get this turned in. So make sure that you work with your group. I'm gonna go through here and show you again, some of you guys may not have signed up for groups, and I got a few emails from people saying that they were not able to figure out how to sign up for groups or find the email that I sent to show you how to. So I'm gonna pause the video, and then in a second, when I come back, I'm gonna come back as a student. Yeah, so let me go ahead and share my screen. And so you should be seeing me as a demo student up here. And to get here and to sign up for a group, you can see I'm already in this this group that is just for instructor use only. So to get into a group, what you're going to do is you're going to essentially go to communicate and then groups. And then if you click on view available groups, you should be able to, in this case, there's no available groups for me because I've already signed up for one, but you should see the available groups that I've set up. If not, send me an email because I think we're going to need to shut this down by, today is Tuesday, so we're going to probably have to shut it down by tomorrow because groups really need to get rolling with this. So we'll pause the video one more time, come back as myself so we can look through this assignment. And what we're going to do is look at this this week's assignment. Again, this is a group assignment. So I did send an email out last night letting you know that you should do a couple things. You need to get together with your group, figure out who's doing what. You need to figure out where you're going to house this document. I would strongly suggest that you guys get together and meet via some communication mode, be it Zoom, or I know people use Discord and other sources to communicate. You should have signed up again for one of those. I think I had 5 or 6 different groups where you can sign up on a given day, Monday through Friday. I think I said it 8 to 12. So there's various options. Doesn't mean that you have to meet all of those days, but at least a group of you guys should try and meet and figure out where you guys have gone and what the updates are, so you can get this in a timely fashion. I would suggest that you guys at least begin a chat and say that, hey, I can, work on this. We should get together at such and such a time. I would suggest maybe 2 or 3 days prior to. This assignment is going to be due that Monday, so probably maybe that Friday before, or if you guys decided that the weekend is better for you, meet that weekend for an hour or two to get all the pieces together. All right, so I'm going to go into the course content area. And in course content, you would go to experiment number 3, and it's called addition and resolution of vectors. And so let's go ahead and open up this this document. And so in this document, it tells you first off that that you're going to need to follow the procedures as stated in the syllabus. And there's about 7 or 8 components in the syllabus that you need to follow. You need to put together a procedure. You need to put together a summary. So look at those components and make sure you include those components. All right, and so I would suggest that you first watch over these videos. Just cleaned up some of these videos, so all the links should be working properly now. And the first video talks about how to use the simulation. So give me 1 second here while this commercial goes through. This is a YouTube video, obviously. Okay, so this guy's going to talk about the simulation. So I'm going to walk you through the simulation as well, but this just kind of gives you a little bit more detail as to how to operate the simulator or the sim. Right? And so the second link is the actual simulator. And so you'll just click that little play button, and I would suggest going to the 2D or the lab. You can do either one of these three. This one doesn't really give you too much. It's all one-dimensional stuff. So, and then down here, you can go to one of these two labs. So I think he in this model takes you through the he's looking at the 2D lab. So we'll look at that. And so basically what you're going to do is you're going to be adding vectors. And by adding vectors, what you should know is you should know how to decompose a vector. In other words, I have a vector here, and looking at it, you can kind of see how it's decomposed. It's decomposed into an X component. So there's an X unit vector, unit vector in the X direction. We'll put that up in just a second. And there's a unit vector in the Y direction. And together these two make up A. And so if I click here, you can see those two unit vectors, ace of X and ace of Y. Right? You can also see the magnitude of the vector up here. Now this works on a click system, so you may not be able to get exactly to the number that you want. And you may have to actually scale up in certain instances because the numbers that are in the table that I'm going to show you may be too small. So you'll probably have to scale up a little bit. All right, by a factor of maybe 10, or in some cases you may need to scale down. I don't know. This is what some of the things that you need to discuss with your group. So play around with some of these things. You can add vectors, and that's what we're going to be doing. So here's another vector B with its components. All right, and then the sum of these two vectors. Let's see, how would we get that? The sum of these two vectors, let's go back. I think put these back in here again. So here's A, and here's B. The sum of these two vectors, if you click that button, there's the sum. So you can take that and drag it. And if you remember, you may have used the tip to tail method. We go from the tip of one vector to the tail of the other. You can also play around and put the origin as you wish to fit things as you would like them to fit. I do not believe you have the ability to scale this number up beyond, what it's saying here. So between 20 and -20. But I'll show you what to do in an instance where you have to scale up or scale down. All right. So let me go out here a little bit. All right. So there's 3 parts of this that you're gonna need to work on with your group. The first part is going to be, and you can do it in any order you want, the graphical portion, and this is where you hand draw your graph. And if you look at that, this YouTube video here, I walk you through how to, it's kind of raw footage, some footage that I did in my one of my bedrooms. So it's sorry, we'll just wait 5 seconds for this video to go through. Okay, and you'll see here, let's see if I can skip up a few points. All right, so here, as soon as it catches up, you'll see me use a straight edge. Capture that piece back there. You can kind of see it here, but here, let's pause that. You can see I've drawn a vector relative to the x-axis 30 degrees and another vector relative to the x-axis or the horizontal 120 degrees, and I've pieced those together. Okay, so this is what you would do on in the hand-drawn, the graphical version of this. So this is the graphical. What you see in the PhET simulation is the experimental, and the analytical portion of this is done by you doing the math and breaking down these components. So here's some analytical portion of this that I talk you through. All right. You should also know how to find magnitude and direction. You can kind of see that over here. So all these pieces are really important. So going back to the PhET simulation, coupled with what you're going to do. So let's kind of split the screen here, put these two together. Where'd my PhET simulation go? Sorry. My PhET simulation. Let's see if I can minimize it a little bit. All right, so here's my simulation. And now this is just some of the information that is in your book. So you're going to need to go to your lab manual to get the other, let's see, we have 1, 2, 3, 4, 5 different scenarios that you're going to need to go through. And so we'll start with the first one. So, and I think this is the example that you'll see in the YouTube video. So you'll have a vector of, this is also really important. F1 is a magnitude of 0.2 times 9.8 newtons. Now, how did I get that? So the author in this book and several other books like to write things in terms of G. Maybe you heard of G forces. So this is 0.2 G forces. And so what you'll do is you'll just take the 0.2. If you want to figure out what it is numerically, it's 0.2 times 9.8. And so 0.2 times 9.8 is roughly about 1.96, or let's just say 2 newtons. So F1 and F2 are forces that are roughly 2 newtons of magnitudes. Make sure you define your units as well. Anytime you use an abbreviation in any of your reports, the first time you use that abbreviation, define what it is. Thereafter, you're free to use that abbreviation, especially on graphs, charts, and tables. It's really hard for the reader to know what you're talking about. So make the assumption that the reader has no idea what you're talking about. You want to break it down as simple as possible. Okay, so in this case, we have 2 forces, and we're on the right side here of my simulation. And so let's clean this up. I think I can hit that. Yeah. And so it's going to be kind of hard to look at this from the standpoint of a vector that's only 2 units of magnitude. Right now, it's directed at 0 degrees relative to the x-axis. So I don't think you can scale it up from the standpoint of just asking this thing to or zoom in. So what you're going to have to do is just kind of scale this up. Instead of 2, maybe you decide that 20 is your magnitude, or the 1.96, or in this case, it would probably be closest to 19.6. but this thing isn't gonna get you exactly to that value. So this just kind of gives you a visual. So this uses some kind of click system, and it doesn't click precisely at those numbers. So just remember, you may have to scale up or scale down. All right, so our number we're going to use, instead of 1.96, we'll just say that the magnitude is going to be 20, right? And we're going to have a directed angle relative to the x-axis. Let's see here. You can see the number here. I think I can plug it in here to show values, but yeah, do it here. So you can see right in there that my direction is roughly about 30 degrees. And let's extend this to about our 1.96 or 19.6 scaled up, right? And so there's our first force, probably F1. And you can see it has X component of 17 or 1.7 if I scaled it down, and Y components of 10 or 1 if I scaled it down. All right, so then we add in our second vector. And so our second vector, we can place anywhere we want. Sometimes it'll come in right here at the origin, but let's just place it, since we're going to be adding these vectors. Actually, let's take that one away. It's going to be kind of hard to see all these values. Let's take this one away. So let's place it here. And then let's rotate it 120 degrees. So I'm looking at the angle up above here for B. And so relative to the x-axis is that you're gonna get to roughly about 120 degrees. Remember, this is not gonna be exact. And we want a magnitude again of 20. So I'm looking at that magnitude right above where my right here. You can see that I am roughly there. All right, so now we'll drag that open to not change the magnitude and direction. You can see where my new vector is. So S is just basically a summation of those two things. You can play around with some of these arrows here, but S is the summation of those two vectors. And so you can see now, if I put some values on there, that my new vector value is of 27.7 newtons. Scale back down, it would be roughly about 2.8 newtons. And its direction, let's see if I can see that. Its direction relative to the x-axis looks to be roughly around 77 degrees, right? And so some of this stuff might be a little hard to see, and you can kind of move that around. So remember, experimental values are not going to be precise and exact all the time. There's going to be a little bit of room for error. So just be cognizant of that. Our theoretical values would come by way of the analytical portion. So that would be this column here. And the experimental portion comes by way of what you're seeing here in the PhET simulation, right? So we're looking for 3 different areas. And so on your report, what you guys are gonna have to do is you're gonna have to design and figure out how you're gonna want all this stuff to look. In the past, what I've had people do is I've had people in the face-to-face lab draw them in a table and submit it, but that gets a little bit clunky. So I would suggest that you submit 1 page per graph. Right? And so like if this were if I was satisfied with this, I would probably do a snip or a copy and paste. So there's a snip tool built into most of you guys's computers. It is called snipping tool. And so I would just so it probably looks like this, or maybe another piece, another name for it now. I would just select new, and then Let's see, new. And then do a screenshot or snip what I'm interested in, and then add whatever details as necessary. So I would maybe save this, copy and paste it into a Word document, and then type something in. Right. So in that last experiment that you submitted, some of you guys submitted hand-drawn stuff. The only hand-drawn things that you're going to submit for this experiment are going to be those that are in the graphical portion of this. And even those should be very neat. Make sure you use a straight edge or a ruler of some kind with some measuring device so that we can see what the units are and write the units on your actual graph as well. Okay. And so that should pretty much explain what I'm looking for, I'm hoping. Let's see. So yeah, so those three portions. I talk about how you should not put it into that table, rather create a separate page for each graph, and if necessary for the analytical portion of this. So I'm looking for one file. You can have multiple pages in the file, but don't create separate files for separate pages. Some of you guys submitted in that last report submissions of 5 separate pages of separate files of each single file, and those are really long, hard for me to grade. I have to go in and out. So I think I'm going to probably force you guys to submit only one single document. So make sure you do that. Make sure that the group comes to an understanding. Finally, before you submit, make sure that everybody looks over this document. Make sure everybody's clear with what you were doing. If necessary, I would suggest that you guys, as a single entity, do the entire experiment and then put your piece or pieces together. And so that you guys are all working together as a team. That's one of the concepts and one of the objectives of this class is for you guys to work together in groups cooperatively. So if you have any questions, feel free to give me a call or email me. I'm going to stop sharing on my screen here and the recording, and hopefully this finds you well.